Hello everyone, and on behalf of the Victorian team at the Institute of Architects, I'd like to offer you a warm welcome to today's Lean-In, Automating a Pathway to Net Zero Buildings, a presentation by Finding Infinity and Neuron on a tool they're developing to rapidly assess any project's optimal pathway to net zero using only cost-effective initiatives. My name is Stephanie Bullock and I'm from Cassells Architecture and sit on the Institute's Victorian Chapter Council, and it's my honour to be your host and moderator for today's Lean-In session. We're joining from across the country today, and we acknowledge with deep respect the traditional owners of this land. We acknowledge that it is a privilege to stand on country and walk in the footsteps of those before us, and we pay our respects to elders past, present and emerging. The Lean-In session is being recorded, so if you miss anything today or have to leave early, we'll be publishing this recording on the Institute's YouTube channel in the next couple of days, and we will share that link with you in our upcoming email communications. This Lean-In session enables you to ask questions of our panellists, so if you have a question or comment, please use the Q&A box at the bottom of the screen to add yours in, and we'll go through these later in the session. Our presenters today include Ross Harding from Finding Infinity, who is equal parts troublemaker, technical mind and artist. Harding is one of the most enthusiastic, optimistic and cheeky engineers you'll ever meet. A rare combination of dreamer and schemer, he thinks big picture about transforming cities around the world to become completely self-sufficient, at the same time as working tirelessly with his team at Finding Infinity to actually make it happen. Operating across a range of scales, from citywide master planning to precincts, building design and even temporary events, Finding Infinity are doing their best at turning dreams into reality. Ross is also joined by Will Young, also from Finding Infinity, who is a sustainability professional with a background in engineering and finance. Will performs detailed building simulations and cost-benefit analyses and provides bespoke advice on projects ranging from houses to citywide master plans. He advises on energy efficiency, renewable energy generation, water efficiency, water collection, treatment and reuse, zero waste, minimising impacts of building materials and low-carbon transport opportunities. And finally, we also have joining us Steve Cassells, who is a director of Neuron, a specialist engineering advisory firm that supports projects with rapid early structural and building services, MEP, engineering advice. Over the last 2.5 years, Steve and his team have supported over 300 projects across Australia. His 15 years of experience delivering complex projects and leadership in the digitalisation of engineering design provides a truly unique lens to view the cutting edge versus the bleeding edge and discuss the latest industry trends and technologies that will ultimately form the pillars of the solutions to some of the most complex and intertwined challenges ever faced by our industry. So I'll now hand over to Ross, Will and Steve. Thank you.
Hey guys. All right, I'm going to provide a little intro and then hand it over to Will, who's going to do a bit more of a deep dive, and then Steve's going to share with us what they're up to at the same time. So bigger picture, our kind of philosophy on this topic is that we've reached this turning point in history in which it's now possible to create profitable projects that have a positive impact on the environment, and probably the challenge is deploying them. So we're excited to share something with you today that we've been working on for many years now. It's sort of there to make it easier for people to know how to make this stuff happen. For us, on every project, our goal is to hit probably three things which sound a little bit contradictory. So zero environmental impact, zero operating costs, and on budget. So might sound like an impossible combination, but that's kind of what we're passionate about, trying to problem solve on projects. And a lot of what we've sort of learned over the years is from failure, to be honest. Like, we've worked on so many projects and failed so many times that we've got really good at learning from all of that failure. And what we've found often is that, like, most projects are just missing so many important opportunities that are sort of really in these early decision-making phases. And often it's because it either sort of took too long to calculate, or sort of we didn't provide the information fast enough and the design was already locked in, or, you know, we took too long simulating things, or even to try and find a detailed price on something early enough that we could sort of gain support of the decision makers along the way. I think the other thing that's worth sort of pointing out is that over the years, we sort of slowly moved our way up the food chain. And like, rather than kind of getting involved at the project where you've already got a fully formed design, and then we're sort of brought in to try and help sort of sustainabilize it, we've sort of found that we can get involved really early in on projects. So often working direct with developers, sometimes before design teams are even engaged. And that now allows us to sort of bake in the environmental costs and the operating costs into the feasibility study. We've learned that like to move fast and become more efficient over time. So it kind of got to this point where we were sort of doing all these numbers and calculations in about like sort of 4 weeks instead of 6 months, which it sort of initially took us. And then, but to be honest, still sometimes we find on projects 4 weeks is still too long for a lot of these really important decisions to be made. And so then at some point in time, we became friends with these guys at Neuron. So Steve's here today. And I guess they opened our eyes up to sort of this ability to use tech to help us sort of take that from, say, 4 weeks to like almost, 1 to 2 days in a sense. And that's what they've been doing with building services. And so they've sort of helped teach us how to apply that to the environmental components. And I think even if nothing else you take from today, I think it's probably interesting to look at what we're all doing in the construction industry and kind of see how we can sort of find ways of cutting corners and saving time on things that we're often sort of like doing repetitively and sort of inefficiently. So for us, it was kind of engineering love at first sight when we met Neuron. And like, I guess today, generally, we're going to give you a little sneak preview of something that like we've actually kind of now finally just released, but we haven't actually started using it on projects yet. So it's very fresh and we're just refining it as we go. And the other thing to set context is that we've sort of set it up for multi-unit residential as a starting point because we're in a housing crisis. But then the next step will be retrofit and then, moving on from there. So basically this kind of started because we just put it online and then the AIA reached out and said, hey, we'd love you to share that with our members. So hopefully what we share today is helpful. And I'll hand it over to Will to show you more.
Cool, thank you. So I'm just going to share my screen now. Cool. So this is just a live look inside the tool that we're developing. As Ross said, it's sort of in development currently. It's designed so that you can put sort of the least amount of inputs you need to put in and get outputs of what environmental initiatives we would recommend on a project and how far that gets you on your pathway towards net zero. So I'll start by going through the types of inputs we're looking at. So this is a real fake project that Steve and I have just pulled together to run the same sort of numbers on. So Neuron will run their numbers on the same building. So it's an invented address in Fitzroy, located in Melbourne, 9 floors, 1 building. It's a new building. So then you just need to enter their areas. So apartments. So this is the residential portion of the building, residential apartments, 7,400 square meters, 57 residential units, et cetera, et cetera. There's also a secondary space in the building. There's some commercial office space. And then there's also a car park. So we've just entered those inputs. You can keep it as simple as that. You can also go in and enter sort of more advanced inputs. The more detailed you are with your inputs, the more accurate your answer gets. But the tool's designed to really have a first pass on as little inputs as possible.
And also just to set context with that, it's often that's when we can inform that big decision-making process is when there's very little information available. So it's sort of quite handy to have like detailed analysis with when the project still is in a very early massing phase.
Yeah, it's probably also worth noting that at this point, the way we would use this tool is internally, be engaged on a project. We would do all this ourselves. And then you know, with the goal of eventually turning it into something that can, that other people can use. So once you've entered all that information in, you've run your simulation. This is the baseline setup that you get. It estimates energy consumption, water consumption, waste generation, the amount of embodied carbon that's gone into making that building, the amount of carbon that that building generates every year based on its operating energy and waste, and then the operational costs per year. And then it also estimates, you know, the capital cost based on typical build prices for that building. And then it does a bit of scenario analysis. So it looks at 3 different sort of scenarios. So a base case, which is in line with this baseline, a best practice scenario, which is sort of initiatives that are relatively common in Australia, but just doing all the things that make a lot of sense, but aren't particularly, you know, necessarily world-leading initiatives. And then a third scenario, which is world-leading, which is really doing every initiative that we can think of. A lot of them are higher risk or haven't been done as much in Australia, but there's also, you know, potential benefits from those. So going through, it outlines the outcome of each of those scenarios, the energy consumption, water consumption, waste generation, embodied carbon, etc. And it brings that down to the operational costs of those buildings, the capital costs of each of those scenarios, and then the payback from going from the baseline scenario to each of these higher performance scenarios.
And maybe not fully spelled out, but like baseline is actually just following current minimum compliance. So this is kind of what our whole shtick is, like that minimum compliance isn't good enough and we need to go beyond. And I guess the question is where to focus and how hard to go where. Yeah,
so baseline will pass your sort of town planning requirements and building code requirements. So it's 7-star NatHERS sort of and yeah, passing scores and all the council compliance stuff. So we then go into an optimized scenario, and this is sort of picking the greatest hit. So it takes the best initiatives from those 2 world-leading and best practice scenarios, and creates a scenario where only the cost-effective initiatives are implemented. So it then gives you those same sort of outputs for those, but then demonstrates here the sort of cumulative impact of each of those initiatives and how close you're getting to net zero. So you can see on this building, it's a 9-story building in an urban environment where I've actually switched off one of the initiatives that an anaerobic digester, because I didn't want to have to go into what anaerobic digestion is because we don't have time.
Well, it's worth explaining though. So this is the baseline energy consumption, for example, for that minimum compliance building. And then these are all the step downs of how to get to zero from there. So this is just showing impact, the same for water, the same for waste, the same for embodied carbon. But then really where we find that this is helpful to talk to developers about is basically understanding for every single one of those initiatives. We tend to have quite detailed cost analysis on the capital cost of each of them, the environmental benefit that comes from that, the annual running cost benefit that comes from that, the payback periods for each individually, spatial requirements, lifespan. So we can kind of provide this like quite customized, detailed analysis, but very sort of simplified. So it's like quick and easy.
Cool. And so then it summarizes your sort of overall scenario.
And also just there, like probably the overall is quite interesting. Like, so that's around about a $1 million uplift on a $52 million building, but you're basically getting around about a 91% reduction in energy consumption, including generation on site, 42% reduction in water, 58% reduction in waste. And like we have the ability to take it to 100 on each of these if we need to, the total savings, and then the paybacks.
Cool. So then this is sort of the web version of the tool. We would then go to this, you generate a report. And so this is designed to sort of replicate what we would typically offer as a concept design report if we were fully engaged for a project. So I'll just go through sort of where I don't want to go through in too much detail, but I'll go through the sort of the executive summary.
Yeah. Like the reality is we won't have time to take you through the whole thing, but what's interesting is that this is an automated report in some ways. So the turnaround time on this can be quite quick, but you'll see as we go through, it's still quite customized. So it's just interesting to see what you can pull off with tech these days. And it ends up like in almost instantly spitting out the order of 100-page report that has full design guide analysis, like advice on how to implement all of these things. So it's not just saying what to do, it's telling you what it costs. It's also telling you how to do it, basically. So it's a lot of like, it's kind of a decade of cumulative IP that we've just like pulled together in an automated system.
Cool. So starting with some project targets, sort of numbers aside, where are we trying to get to when we start? So net positive energy, water neutrality, zero waste, everything paying back within 10 years. And then also looking on the construction side, zero waste and zero carbon construction, and healthy buildings. Outlining what the baseline is. So operating costs, operating consumption, and embodied carbon, breaking that baseline impact down by its different uses. So, you know, for example, the energy breakdown here, how much of the energy in the baseline is consumed by lights, equipment, heating and cooling systems, domestic hot water, etc. Moving through to water.
And also, I think what's worth knowing about this is like, it takes a long time per location that we set up in. So we've actually done every different scenario for this building typology in a sense, for example, in Melbourne, and we've slowly done it in different cities. And so there's like it's a huge amount of data that we've pulled together in advance that allows us to kind of like then pull from that data to apply it to based on the specific inputs from that are there. So it's like months of work in advance, but then it allows us to give that answer quite quickly.
Yeah. Then outlines a proposed scenario. So based on all those initiatives that we discussed earlier in the web tool, laying them all out on a diagram and showing the impacts, breaking that down in sort of a schematic sense. So what that looks like in section, how flows of materials and flows of resources work. Again, breaking down the step down diagram that we saw earlier. And then the summary table. So the cost impact of all of the initiatives, same summary table as we saw earlier, breaking that down those costs per apartment. So it can really help to estimate, you know, how much does an apartment cost to run in our baseline scenario, but then how much can we reduce that, and how much per apartment are we actually paying excess in capital costs.
And so this is the kind of thing that we'd find that, say, the marketing team with a developer might find quite helpful is, you know, often it's like, yeah, but, you know, we don't get the financial benefit of this. Why would we spend that extra $1 million on this project? It's like, well, actually, you've got a more valuable product that you can sell to people, for example. So there's just so much data here that we've kind of got the ability to extract it and communicate it how we need to.
Cool. And sort of a summary of the outcome, increase in capital costs, reduction in operational expenses, and reduction in emissions, and then breaking that down by energy, water, and waste. And then it goes into more detail. So I'm not going to flick through all of these slides because we'd probably better give Steve a chance to introduce Neuron. But I'll just flick through super quickly the detailed breakdown. So all of this information is being sort of generated for the specific location and specific floor area of the building. It'll select relevant case studies, break down proposed versus baseline energy consumption and generation, same with water, same with waste, same with carbon over time, and then it gets into sort of full detail of all of the initiatives. So I'll just sort of very quickly flick through all of the rest of these slides, but
I think particularly seeing how you actually apply this to the design, like the thickness of the inch, it's not just theoretical, it's very like, it's sort of upfront providing a design guideline in a sense. Cool.
And then breaking down all of the sort of parameters that have gone into doing all of these calculations as well.
All right, let's hand it over to Steve, who I guess probably part of the connection between us and Steve is that we're completely separate businesses, but we work on projects a lot together. And it's because weirdly, probably between the environmental costs and the building services costs, they're often the two costs that the QS is not doing because it needs a certain level of expertise. And I think that's where we've sort of found a niche working together, is that everyone says, oh, that's too expensive. And we kind of like to call bullshit on that, to be frank. And so we like to just show people what these costs are and what those impacts are. So certain costs we can do, certain costs that Steve can do that we can't. So it's probably one way of showing a connection, but and also I'll hand it over to Steve.
Identifying opportunities for savings that can offset some of those costs. So for example, we'll look at reducing the amount of glazing in a building and how much we can save through that. But then Steve will also point out some areas where they can look at reducing costs of services to offset some of the costs of these initiatives.
Cool. Thank you very much. And it's a good segue. I might actually just hone in on some of those points in a moment. But yeah, as Stephanie said at the start, I'm one of the 4 founders of Neuron. We're a building services and structural advisory business. I guess before I dive into this working example, which is going to make up of 90% of what I'm going to say, I guess just for context, our business is made up of 2 components. We call it shaping and advisory. So the shaping is the lion's share of our business, which is helping new projects get off the ground. And then that usually has from site acquisition right through to town planning submission, where all the big decisions get made. We would call that the design component. And then what we usually want to do then is post town planning submission, when it's approved, we want to document that design. And then the second half of our business is essentially an advisory role where we stay on as client-side engineer, managing documentation consultants. So we're a little bit different, a little bit unusual, not your typical building services engineering firm. And we've done it this way by design because I guess our mission was to help as many people as possible to engineer better buildings. And we wanted to do that at scale. And to do that, we needed to be able to productize the building services engineering process. So that's essentially what I'm going to show you now. It's our productized version of how we get from site acquisition through to town planning submission. And the interactions that we have with other consultants, of course, Ross and Will are ones we interact a lot with, but we also interact with civil and acoustics and other consultants. And so we have sort of digitized those processes. We've been at this for 2.5 years. And yeah, I think it's about $60 billion on the books at the moment that we've been working on. We only have 15 staff. So to do that sort of amount of work, you need to have a highly digitized workflow. So if I take the example, I've just shared my screen. So hopefully you're looking at Neuron at the moment. And I've seen some of the questions come through on costs. So I might see if I can answer some of those costs as I go through. So we have our building, 189 Johnson Street, that we've made up for this purpose of this demonstration. And I guess where we would normally get involved is at the site acquisition phase. Just open that out a little bit. We would normally come on while they're acquiring the site, looking at the site. One of the first things that we do is delve before you dig assessments and looking at utility infrastructure around the site. So our reports cover lots of various things, including utility assessments and drawings. We have a drawing tool. But I guess the really interesting component and the main focus of this is the what if questions. So we don't want to copy and paste old buildings. We want to design them better than what we did before. So this is our building services tool. We've got several tools in these areas. We also have a London office and a small team over there. But how we run it is the exact same way. So we'll literally give it a name. Will literally sent me over, hey, Steve, here's our project. Here's the apartment mix of 1 beds, 2 beds, and 3 beds. There's 2 levels of car parking, 139 car parking spaces. And I think actually, Will, you said it had 3 commercial tenancies on level 1 ground floor. So we take those inputs. Those input questions run calculations. So Neuron is essentially a massive calculator, and Ross and Will's tool is also a massive calculator that just runs industry standard calculations, or in their sense, they're all of their own IP. We, of course, have generated all of our own dynamic calculators as well. This is probably 23 people who've been involved in building this, and it's our life's work. So I just ran this through just before I jump on the call. And now I want to talk about this net zero. So we love what if questions. We think curiosity and challenging the status quo is the way to result in better buildings. What we need is the ability to have the data to inform that decision. So a very common thing that we look at is once we run Neuron, it runs about 4,700 calcs and outputs lots and lots and lots of data. So I'm just going to pick two quick things just to give you a taste for how myself and Will and Ross work on projects together. So you've just seen they've ran their assessment and they've figured out that pathway to net zero. And of course, you've probably spotted it's an all-electric building, lots of solar panels on the roof. So that's just two components of it. So that'd be a very common thing that we would see working with Ross. So from our perspective, the roof is key. So what are we going to do with the roof? So if we looked at what's on the roof, what do we actually have up there? We had a preliminary allowance for some solar panels, but we also have stair pressurization fans and library relief fans, and you can see here roof-mounted VRV condensers, hot water plant, MATV antenna. And all of this stuff needs a home. We have standard details that we can show you how it connects up. So this is a problem because all of this plant is going to erode the ability to maximize solar panels on the roof. So what are our options? So one of the things that we have is all your air conditioning options. So for this 189 Johnson Street, what if we did splits and balconies, or we did roof-mounted VRV, or on-floor one-to-one DX splits? Now, our costs, these are bottom-up bill of quantities. We are not quantity surveyors. However, quantity surveyors really struggle with building services cost estimates because they're not given anything to price. So it's very difficult during the early phase. All they can do really is square meter rates or per apartment rates. As you know, engineering doesn't work that way. It's all in the detail. So the way this works, these are bottom-up bill of quantities. So I know the apartment mix. I can size Fanco units for 1 beds, 2 beds, and 3 beds using kilowatt per square meter estimates. And I know the mix, I know the number of them. Same, I know the number of apartments per level. I know the number of levels. So we're able to estimate hangers and insulation and installation for vertical reticulation and horizontal reticulation. These use Ronaldson's. We've got partnerships, Ream for our hot water systems and Dakin for our air conditioning systems. We also work for several builders. So there is no magic button for cost. Cost, of course, is very difficult, not only to come up with, but also to maintain in a highly dynamic environment. But we put a lot of effort into it. So this gets a lot of attention from us on a weekly basis. I guess what we look for is two components, the costs and the value of space. Because really there's only 3 parts of development. There's how much you buy the land, how much it costs to build the building, and how much you can sell or rent the building for. Hopefully that equates to a margin. So the way we look at it is Ross and Will take care of all of the environmental impact. We look at the capital cost of each of these systems. And then what we think is quite novel, quite unique idea is we look at the value of space. So one of the questions I always ask a developer is how much is every square meter of your building worth, both the basement and a typical level and the most upper level. And they might say, you know, if we had a set of plans like here, they might say, look, this ground level is worth $10,000. The penthouse is worth $35,000. So we put those in and it's just multiply A by B. And then like this one, I just used $15,000 per square meter. So when we're looking at these different air conditioning options, I can see not only the capital costs, but I can see the value of the space. So in this example, Johnson Street, if we took the condensers off the roof, that centralized VRV system, which was this one here, we're talking from 961,000. If they could go on the balconies, 416, the client might say no, the council might say no, that of course we need to do manually, or we could put it in an on-floor plant room at 498 square meters. However, that 130 square meters is equated to almost $2 million worth of potential lost sellable space. So lots of numbers. It enables us to have the same conversations we normally have, but usually within about 45 minutes on a call just like this, we can work through all of this. We go, Will, what are you thinking? I'm thinking this. What does this mean? Okay, well, if you go all electric, if you want to go single phase instantaneous or centralized heat pumps, here's the cost and spatial impacts. You might say, Steve, I think the number there was $1 million extra. We need $1 million worth of savings. Okay, well, what can we get? What happens if we do CFD in the car park? What happens if we do a pad mount substation instead of an indoor substation? Can it work? Let's have a look at the plans. And then we can drop these on. So these are all shapes. This is still Neuron. These are all to scale, so we can quickly drop on substations, drop on switch rooms, talk about locations. Is it valuable space? And then these have attributes. So as we move stuff around, like this one here, I can say start to level 4 and goes to level 6. So as we move different elements around, I can see it move between different on different levels. So it takes 2D PDFs and turns them into 3D conversations. So to be honest, on most projects we're working with, Will and Ross, we're walking away from that kickoff meeting on week 1 before any architects have spent any of their fees or made commitments to yields, or the feasibilities have been wrapped up. We're able to run these reports, so it all comes out in report format. It's not just numbers, of course. So we have fully automated reports that go through all of the systems, all of the options with those costs. Also, there's pros and cons and explanations of them. That enables us to lock in what we call our preferred services strategy, which is here, chosen system. And then we then rerun it under the preference sections. We select, okay, we're doing an indoor substation, we're doing this type of hot water system, we're doing this type of air conditioning systems, the on floor. I'll just close that. And then at the end of that meeting, we will issue this, which is called a design guide, which is specifically for architects. And then it goes through every single system we've just discussed, including all the other stuff like fire pumps and tanks and brigade booster assemblies. So if you're a highly experienced architect, you know what all this stuff is, you just want it on a table, there you go. And then if you're a junior architect or you want to learn what is a stair pressurization system, we have a little half-page illustration of every single system explaining what it is, where it needs to go, and the sort of do's and don'ts. And this is, I run this as a lecture series at RMIT in Vic and UTS in New South Wales. So the content of this is not generic, like it's all dynamic placeholders, so that literally needs a stair press shaft of 1.1 square meters. This is written like you've never heard of any of this before. And I feel like Ross and Will's great strength is communicating. I have sat in a lot of sustainability meetings where meeting 1 is a huge Excel sheet and people sort of get lost in the complexity. So I feel like the trick of achieving net zero is it needs to be easy to understand, it needs to be compelling to get people excited, and it needs to be within budget. So by having these sort of 3 components that we have pulled together, where we essentially flip it, like Ross said, we flip it so this becomes a briefing session at the start of a project, not a consideration 10 weeks later when you've already signed off the feasibility, they've bought the land and the budget's locked in and there's not much you can change. We're able to front load the project with the right conversations, the right data, and still have reports. You saw Will and Ross, it's a PDF report you can print. These are PDF reports you can print. So we've tried to create all of this information to just replicate what a traditional tier 1 consultant group would give you. But hopefully you can see that by automating this process, we're basically just compressing all of the important decisions into the first 2 weeks before commitments get made, so people are making informed decisions, and go from there.
Awesome. Shall I just wrap up and then we move into some questions? What you done there, Steve? Yeah.
I'm done.
I think in summary, like I think we've all probably, it's not our first rodeo, and it's sort of there's enough projects we've probably all worked on that have sort of, like we all talk about environment, we all talk about landscape. Then we get to the end of the project, it's all too expensive and we have to value manage that stuff out. A lot of this stuff is just being eyes wide open and knowing exactly what all of these cost estimates are, knowing what all of these spatial requirements are up front in the project, baking them into the FISO, baking them into the spatials and the design, and then ensuring that they actually do happen. So hopefully that's been helpful. Maybe just, I don't know if, Steph, you wanted to facilitate questions, or if anyone just wants to write in, but feel free to grill us on anything you want, and we're there to help out.
Thanks, everyone. That was fantastic. And there have been some questions, but I think you've been answering them as you go. But given we've got time, it might be an opportunity to drill into some of them a bit more. So there's obviously been a huge amount of IP that each of you have invested in this, not just upfront, but also in maintaining the system. Can you talk each a little bit more about where your data comes from?
Yeah. So from our side, I guess in some ways, as I sort of mentioned, it used to take us 6 months to do this stuff, right? And it was sort of like, I remember doing it on big master plans and things like this. And you would, like the old fashioned way was like, you would kind of work through the master planning process together with everyone. We would do a bunch of ideas of what we could look into. And then we would write to suppliers and say, hey, we need a water treatment plant. What does that cost? We need a waste to energy plant. What does that cost? We might want to look into centralized versus decentralized heating system. What does that cost? Like doing it as we go. And I guess, I sort of 20 years later, you sort of collect all of that information and you don't necessarily have to go and reach out to people for it the first time. So there's a lot of cost analysis there that we also need to keep our finger on the pulse, which is sort of like solar changes, batteries change, like it's all changing that we need to be aware of. We need to be aware of the latest technology, but then also it needs to be more scientific than just having like rough areas and costs. So a lot of it is when we put areas into buildings, there's preloaded analysis that we've done to help us size different equipment. So for example, the heat pump, we've got cost estimates in there based on actually the number of apartments and, the building typology and things like this. So it's sort of intentionally trying to be simple inputs and sort of complex outputs with the sort of analysis behind it. But for us to be simple about it, it kind of means a huge amount of energy modeling in advance. And it also is sort of a lot of spreadsheets that we've done to do these calculations. And then they can all link back to areas and allow us to kind of work through it from there.
Great, thank you. Another question that came up that I think you may have already partly answered is around the value of creating that baseline. So I don't think you're suggesting that baseline is a scenario that anybody would want, but can you talk about how powerful it is to have that baseline in terms of looking at things like payback and comparing options?
Totally. And I guess something as a person who's really passionate about the environment, I actually found that trying to get people to care was made people feel uncomfortable, to be honest. And I actually found that the more impartial we were, the more objective we were, the more that we used finance as a metric that we could talk to people with, it meant that we were like, hey, you can do this if you want, or you can do this. But we like to find a better way. And it's sort of, we like to talk about it as the Godfather, like make them an offer they can't refuse. And that's where it's sort of like, if it's on budget or saves them money, and it's like, if it can reduce environmental impact and all of these things, it just depends on where people are at. And for us, some clients, they're like, of course we wouldn't put gas in a building. Like, why are you like even proposing that? Well, great, sweet, we agree, that's the baseline. But we do have lots of clients that are like still in that phase. We work all over the country, and certain people do not get it. And they just still think that apartments need gas for cooking. They still think that's what they need to like sell. So this is a perfect example of where we jam with Steve, is that we'll do the analysis. We can demonstrate the environmental impact and all of the benefit. We can help communicate the like impact on running costs. But then also Steve goes down to the point of knowing the substation size, the cost of removing the gas connection, all of that. So together, there's this really exciting business proposition that says, hey, we're going to save you $1 million up front on not having that gas connection and reducing the substation size. We'll fit it in, don't worry about it. And we're going to save you, like, instead of it costing $65 per apartment, for gas per month, it's going to be $17 a month. So it's just like, it won't cost you more up front. It won't cost you more in the running costs. But yeah, unfortunately, some of those clients still need that information. But I must say, coming back to the power of architecture, like a good architect, I think, does go forwards and say, of course we won't do gas. And then we don't even have to do those numbers. Do you know what I mean? Like that's a more efficient way of going about it for sure.
Right, thank you. There's another question that's come through. I'm not sure if you guys can see that. Just asking about, there's been a lot of discussion about operational energy costs and savings, and just asking about what the tool can do in terms of embodied energy savings, and whether it covers that, or whether, if it doesn't, whether it will in the future.
Right, good question. Yes, so it's been a bit of a journey for us. Like, it always started as energy, water, waste, and then we worked out that people were interested in running costs, and then we got more and more into embodied carbon. It's a funny balance with embodied carbon, because there are certain projects that will do like a detailed LCA, for example, and we can get quite accurate, I mean, as accurate as possible data on that stuff. But the level of input information that you need at early phases in projects it's impossible to get that information. You can't get the specific volumes and quantities of all the materials that are going to go into it at the beginning. So what we actually find is often helpful is almost like there's a little bit of like crude, rough estimates that are really early on in projects that can show people the like best bang for buck moves that you can focus on. And that might be from any material that we can go into, but more recommendations of what to do, rather than getting to the end of the project and having such detailed analysis, but it's too late to actually change anything. So it's a constant balance for us, is finding that like accuracy versus like timing, and like imperfection versus action. But yes, we do embodied carbon analysis in that, and it uses like previous projects that we've worked on and previous typologies, points out what's good, what's bad. But I must say, like, I feel like anyone who thinks they've got that stuff perfectly worked out, I think, is lying to you. It's a journey that we're all going on, and most products and like materials out there still are lacking a lot of information. So it's about us all working together to try and like kind of refine that as we go. But there is some great things that we can definitely do right now that we're all ready to roll on. And then it's about trying to close that gap together as we go.
And at a concept design stage, it's about like recommending like what are the significant impacts that you can have by going between one thing and another.
Yeah.
Is it a timber structure? Is it, what's the facade? These the big moves at the start.
And for example, often it's talked about a structure, but also like, we're finding facades sometimes have like 25-50% of the embodied carbon in the project, and they're not even fully thought through. Services can have sometimes 20-25% of the embodied emissions in it as well, that is often not even like, calculated. So it's sort of, we like to break it down bigger picture. Let's focus here, here, and here, best bang for buck, and let's try and knock those things off as best we can.
Right, thank you.
To add to that, Stephanie, before you move on, I guess that's an area that we've seen huge growth in our London business, and we've only been there a couple of months. City of London are, miles ahead, to be honest, and they're required to do not only a full embodied carbon breakdown for their equivalent of town planning submission, but to actually run various scenarios of the building and to prove that you found the lowest scenario with the lowest embodied carbon. So they're actually front-loading Revit modeling of all of their services and structure and architecture, so they can run those models to actually get through the planning process. So overseas, I know we're starting to talk about it, and I'm not sure how many people understand what it means sometimes. For what Ross just said, their structure, facade, services, that they're huge. They're like a big component of it. So I think it's an area that our structural tool has it. I won't show that because it's too deep of a rabbit hole. And we're building a services one now, because Ross is spot on some projects, it's up to 20% of embodied carbon as you're building services. So it's an area that we're very focused on. One, because it's mandatory in London, but two, because we think it's coming in Australia. I can't see how it won't be mandatory in the next 5 or 10 years.
Thanks, Steve. So we've got a little bit of time still. So I think we do have time to talk a little bit about waste. So there's a question here about how big a residential project needs to be able to treat organic waste for energy generation. Like, at what scale does that become a viable consideration?
Yes, good question. Look, it's we find we're pretty in tune with what technologies out there that's cost effective, and it actually, part of it is buying the tech, part of it is who's going to run the technology. And so we do have different products that you can use at a smaller scale
Down to an individual house.
Yeah, from like one house up to, you know, like a typical apartment building might be 500 kgs a day in up to like, you know, a ton a day or something. So there might be like sort of in that range. There's products that we have that can do that, but then you don't necessarily have the willingness and the enthusiasm for someone to run that machine. So it's usually, we are often like the one piece of equipment that we have extremely sort of great financial sort of performance on is 10 tons a day, which is huge. It's about probably 10 apartment buildings. It's better on a precinct type scale. Sort of 150 of them would consume all of Melbourne's food waste. Yeah, exactly. So it's like, it's, you know, 10 tons a day is quite a lot. So, and to be honest, to be simple about it, often it's like, if it's below that, it tends to be doing on-site sort of like worm farms, composting, other systems, or trying to connect in with organic waste collection tends to be what we find is an outcome on projects. Saying that there are other ways, it's just we find that they often don't end up happening, to be honest. But it is a part of our philosophy is not to overly generalize either, which is where we like kind of like this like mass customization type approach. But yeah.
Unless you can afford to pay somebody to run it from the profits that the tech itself is making, then that's sort of the threshold for, you know, whether it's going to make operational sense, I guess.
The other typology we see, Stephanie, where it tends to make a lot of sense is you've probably seen a lot of rezoning of rural land on the outskirts of cities that can sometimes not have municipal infrastructure. So no sewer mains, limited water mains, limited available power capacity. And as soon as you get into developer contributions, which would be in the millions and millions, if not tens of millions, then all of a sudden, anything you can do to limit your load and impact is being well received by the utilities. So I know there's one in a power plant doing a lot of work with City Power and Gemini on things that they can do to minimize having to run that 2 kilometers of transmission lines or to upgrade that sewer mains by 4K. So those type precincts really start to make a lot of sense as well. And there's plenty of live examples around the country of those.
Yeah, it's a great point, Steve. And I think, you know, holistically, you know, what you're able to provide in terms of providing the economic argument to support the emotional argument is clearly very powerful. I'm sure a lot of people like me are thinking, because how soon can this extend to other typologies as well? You know, there is a housing crisis. Obviously, multi-res is very important, but there's a lot of other building typologies that could really benefit from this. What's your thinking in terms of expanding this to other sectors?
So we've probably got slightly different stories. Steve's got a number of tools that are already ready to roll. From our side, we currently work on all different building typologies. It's just getting the tool ready for it. And so it probably is a bit demand based. At this stage, we're working with the multi-res, but we can, from our perspective, we're probably pretty keen to get it onto retrofit next. But then commercial is not too far a step away, and then it kind of just becomes a question of like whether there's the demand. But I'll let Steve speak to that as well.
Our one, yeah, we started in multi-res, as that's the one that's been around the longest. And we got a big federal government grant 2 years ago to build a commercial tool that was highly complex. From our perspective, residential is the simplest built form. Hospitals are the holy grail. So we're trying to get the whole way to hospitals. We've done commercial, resi, aged care, hotel, and then every sub-variant of those, co-living, student accommodation. So that's kind of our current tools. We have one multi-res tool in London, and we are about 50% the way through building a hospital tool. So we've actually got a lot of health engineers in-house. That's our holy grail of most complex types. But exactly what Ross said, we have to build a tool before we can work on any projects. So it's very different, where engineers will usually do whatever you want and we'll do it manually. We have to build a tool first and then offer it to the market. So it's kind of flipped a little bit.
Great, thanks, Steve. And just for those, if you haven't got the Q&A open, somebody from KTA has just dropped another resource into the chat, commenting, unsurprisingly, the Netherlands are also well ahead in terms of this question. So that's a great link. So thank you for sharing that. So we're almost at a close. Maybe just to close out, I might put to each of you, you know, a lot of people watching this will be thinking, this sounds amazing, but how do I get this happening on the project that I'm working on? What would be your advice to them?
I would say chuck us an email.
I thought that was probably the answer, but I thought I'd just check.
Yeah, and look, part of the reason we have created the more tech style is for time efficiency, to be able to help more projects, because we get quite busy at times and it's hard to keep up. So from our side at least, just reach out and share with us any projects, and we're always interested in having a chat. I think and there's probably certain things that, like the multi-res thing, we can help out with this. There's other stuff that it's the same work that we do without the tech on other projects. It's just we're not as set up for it to be as automated. So Steve, I don't know if you want to.
Yeah, no, you're spot on. Just reach out. I'm sure our emails will be circulated. But yeah, the fundamental, to be honest, everything we've just shown you, there's no magic there. It's just highly logical. The magic is getting it in front of everyone early enough where it's easy to bake in those decisions. I always come back to the first 6 weeks. I genuinely feel if we get brought into projects after 6 weeks, we're kind of on the back foot. Decisions are made. The loading dock entrance is locked in. You've already had that first meeting with council. Stuff's getting, it's starting to be real. So putting stuff in gets harder and harder, where if we can have it at the kickoff meeting, the architect hasn't spent too much fee yet, everything's open, we can actually bake this stuff in a lot easier. So yeah, I think just generally speaking, the best way to employ this stuff is as a briefing tool before you start, and then dive into the layout and normal flow then.
I think that's great advice. Generally, you're quite right. The earlier, the better. That was fantastic. So thank you so much to our three presenters. It was incredibly informative and very impressive in terms of the work that's gone into both of those tools and the possibilities there. And I'd also like to thank everybody for joining. Just a reminder that the lean-ins are recorded to view later, and you'll receive notifications of when new lean-ins are available to view by subscribing to the Australian Institute of Architects YouTube channel, YouTube at Oz Architects. And thank you again for your time, everyone, today.
Thanks so much for your time.
Thank you very much, everyone.
Appreciate you organising as well. Thanks, guys.